This is 9-7 factoring special cases. Hopefully you remember from a couple of lessons ago where we learned about the square of a binomial. And so what we're going to be doing today is going backwards using this rule. So we're going to go from a squared plus 2ab plus b squared to a plus b squared. So here are some examples of what we're going to be doing today. We'll start out with a trinomial, and we'll end up with this binomial squared, the square of a binomial. But we have to determine, and actually since it's called factoring special cases, we know that all the trinomials we'll be seeing will all be, at least in those examples, able to be factored into the square of a binomial. But for future reference, we need to be able to tell if it's one of those cases where we can use this rule, the square of a binomial rule. So if you notice when we go from squaring the binomial into a trinomial, you see it's always the first term squared plus 2 times both your terms plus the last term squared. So you want to check and see that your trinomial fits this rule. So your first term squared, so we have the x squared, plus is the middle term 2 times the square root of both your terms. So 2 times x times the square root of 25, which is 5, plus, and then what's the square root of 25? Well, it's 5 squared. So does it fit the rule? Sure. X squared plus 2 times x times 5 is 10x, plus 5 squared is 25. It sure does fit that rule. So in order to tell if a trinomial fits the rule, you really are just checking this middle term. Is the middle term 2 times the square root of both your other terms? The square root, or the square root of your first and your last terms. So yes, 10x is. It is 2 times the square root of your first term times the square root of your last term. So you know that it fits that square of a binomial rule, and therefore the answer is the square root of your first term plus the square root of your last term. All right, let's do some other examples, and maybe it'll start making more sense. So we're factoring a perfect square trinomial with a equal to 1. So by the way, go back to this other slide. These trinomials are called perfect square trinomials. And that's because the first term and the last term are perfect squares, and the original binomial, it's the square of a binomial. So it ends up being a perfect square trinomial. So they're telling us all we're dealing with are perfect square trinomials. But again, you can check to make sure it works to see, is my middle term 2 times the square root of my first term times the square root of my last term, the square root of 9 is 3. 2 times n times 3 is 6n, so that's, again, how you can check to see if it fits your rule. But of course, we know all of these will. So when we factor it, we know that it's always going to end up being the square root of our first term. Since we have a minus sign here, it's that subtraction sign here, minus the square root of your last term, 3, squared. Now, I know that was quick, so let's check it and we'll see it really does work. So m minus 3 squared would be m minus 3 times m minus 3. If we FOIL it out, m times m squared. M times negative 3, negative 3m. Negative 3 times n, negative 3m. Negative 3 times negative 3 plus 9. Combine like terms, m squared minus 6m plus 9. So we do end up with what we started with. So again, in order to factor a perfect square trinomial, it's just the square root of your first term, either plus or minus the square root of your last term. And the plus or minus depends on this sign right here. If they're both plus signs, then you know this is a plus sign. But if your first sign is a minus sign, you know you're going to have a minus sign in your binomial. And this is your answer. So again, I know this was quick. Let's try another one. We need to factor this expression. So again, to factor it, you know you're going to end up with a binomial squared. And inside your binomial, it's always the square root of your first term, x. Look at your signs to determine the sign. So we know since they're both plus signs, I have a plus sign. The square root of your last term, which is 4. This is your answer, x plus 4 squared. Again, if you want to check it, x plus 4 times x plus 4. FOIL it out. X squared plus 4x plus 4x plus 16. Combine like term, x squared plus 8x plus 16. You could also check it by using the rule from a couple lessons ago where we said, okay, the square of a binomial is the first term squared plus 2 times both your terms, so 4, plus your last term squared. And you simplify x squared plus 8x plus 16. So we see either way, either using the rule or by foiling it, we end up with what we started with, so we know our answer is correct. All right, let's do one more, since I know this is a little confusing, but, you know, practice makes perfect. The more you do, the easier it gets. So again, to factor this is called a perfect square trinomial. We know it is. We can check it by making sure that our middle term is the product of 2 times the square root of our first term times the square root of our last term, and it is, in fact, 2 times n times 8 is 16n. We know it's a perfect square trinomial because of that. That's how you can check it. Since it is a perfect square trinomial, it will always factor out to be the square root of your first term, either plus or minus the square root of your last term, squared. And we know it's going to be a minus sign since we have the subtraction sign there, and there's your answer. And again, you can check it by foiling. All right, let's try something else. We're still going to factor a perfect square trinomial, but now a does not equal 1. That just means that you have a coefficient to your n squared term in this case. So it says the area of a square is 16, I guess that's an h squared plus 40h plus 25 inches squared. Find the length of a side. Well, I'll start with the formula for finding the area of a square. And the formula for finding the area of a square is area equals side squared. In this case, they gave us the area, 16h squared plus 40h plus 25. They want us to find what the side is. So basically, we're just finding that binomial. If I factor this into my two binomials, then I'll find out what one of my sides is. So I'm just going to factor it. And again, we can check to see if it's a perfect square trinomial by seeing if this middle term is in fact 2 times the square root of your first term. What's the square root of 16h squared? Well, the square root of 16 is 4. The square root of h squared is h. And then times the square root of your last term, which is 5. 2 times 4h times 5 is 40h, so it is a perfect square trinomial, and we can use our rules to factor it. So it's going to be the square root of my first term, 4h, both plus signs, we have an addition sign here, and the square root of your last term, which is 5 squared. So when we factor this again, we get 4h plus 5 squared is equal to side squared. To get your side alone, we have to do the opposite of squaring, which just means square root both sides. And if we square root both sides, basically square rooting something that's squared, they undo each other. So 4h plus 5 equals f. And there's your answer. Don't let this confuse you. All they wanted you to do was factor. And since we know that the formula for finding the area of a square is side squared, that means our area is 4h plus 5 squared, which means we did 4h plus 5 times 4h plus 5. So that means one side is 4h plus 5. All right, let's look at one more that's not a real-world problem. This is just a quick check 2a. And we're doing the same thing we've been doing. So again, if you want to check to see if it's a perfect square trinomial, just look at the middle term and ask yourself, is this middle term 2 times the square root of my first term times the square root of my last term? 2 times 2 is 4, times 3g, that is 12g. It is a perfect square trinomial. Therefore, it will always factor out to be the square root of your first term, either plus or minus, in this case, minus the square root of your last term squared. And you can always check it again by foiling it out. You can do that on your own. So let's go ahead and do another one. So we're using the same rules. Is this a perfect square trinomial? Again, they all are, since that's the title of this example, but in the future, if you needed to check to determine if it is a perfect square trinomial, you have to see, is my middle term 2 times the square root of my first term times the square root of my last term? And yes, it is. 2t times 9, 18t times 2 36t, since it is a perfect square trinomial, we can use the rule that it will always factor out to be the square root of my first term, 2t, either plus or minus, in this case plus, the square root of my last term squared. Don't forget that squared on the end, because that means 2t plus 9 times 2t plus 9, and that's how you'll end up with 4t squared plus 36t plus 81. Okay, now we're going to move on to the second half of the lesson, which is the difference of two squares. This is a whole other rule, and we also did this a couple of lessons ago, so we're just going to be going backwards. A couple of lessons ago we learned that if you're multiplying two binomials, a plus b times a minus b, so two binomials that have the same two terms, one addition, one subtraction, they will always FOIL out to be, or they will always multiply out to be the first term squared minus the second term squared. So here we have two examples of these difference of two squares, x squared minus 81. So all you have to do is take the square root of your first term and the square root of your last term, and it'll work out to be those two binomials. So we had x plus 9 times x minus 9. And again, 9, that's just the square root of your last term. Same thing here. Take the square root of your first term, 4x, and the square root of your last term, 7, and then you have those two binomials, 4x plus 7 and 4x minus 7. Okay, we're going to move on to an example showing this, but I'd like to wait until the next video. So in the next video, we'll be doing the second half of our lesson, which is over the difference of squares.